So what is intermediate? It is product for one step of a reaction. What is the meaning of carbocation? What is the meaning of hydronium ion? H plus, H3O plus. So carbocation are sp2 hybridized, vacant p orbitals. If he divide his property equally among carbon and chlorine, then it is known as homolytic fission. More the concentration of charge, more easily it will react with negative charge. Carbocation, there is a more dispersion of charge. The first one has more dispersion of charge. Minus I effect decrease the stability of cation. Means the carbocation and plus I must be nearer to each other. Unequal distribution of property, unequal distribution of bond is known as heterolytic fission. And minus I and carbon ion must be, more the plus I effect, more will be the negative charge density on carbon, more will be the unstable. Two minus I effect dominate one strong minus I effect. Hi, hello to everyone and welcome to my class. Now today we are going to discuss what is the application of inductive effect. We already studied what is inductive effect, what is minus I, what is plus I, how inductive effect will operate. Now in today's lecture we will start with application of inductive effect, how we can use inductive effect. Now in application of inductive effect, first we will discuss stability of intermediate. So first of all, is there any intermediate formed in the reaction, how can we determine the stability of intermediate? So today's lecture is based on stability of intermediate. So first of all, what is the definition of intermediate? How to define intermediate of a reaction? Now this is an important definition. Intermediate is a product. Intermediate is a product for one step of a reaction and reactant for another step of a reaction. Means it is a product for one step of a reaction and reactant for another step of a reaction. Means intermediate formed for product for one step of a reaction and reactant for another step of a reaction. Now to understand this, let us take some basic examples. Let us consider this reaction, A gives B and B gives C. This is a two-step reaction. Now which is the intermediate of the reaction? The B is intermediate, the circle represents intermediate. Now why B is intermediate? Because it is product of A and it is reactant of C. So what is intermediate? It is product for one step of a reaction and reactant for another step of a reaction. So by this definition, B is our intermediate. Now let us consider second example. A gives B, B gives C, C gives D. What are the intermediate? B and C are intermediate. Why B is intermediate? Because product of A and reactant of C. Why C is intermediate? Because product of B and reactant of D. Now let us consider third example. A gives B, B gives C, C gives D and D gives E. In this case, B, C, D all are intermediate because they are product for one step and reactant for another step. Now in example 4, B is intermediate. I already explained in example 1, 2, 3. D is intermediate or not? In this example, D is intermediate or not? There was one good question on JEE Advanced. That question was based on the definition of intermediate. If your definition is clear, then you can easily solve that question. Now, D is not intermediate. Why? According to definition, intermediate are those which has reactant for one other step of a reaction and product for another step of a reaction. So by this definition, it is not going further, means there is no product for this step. This means D is not intermediate. Then what is D? D is side product. D is some reactant parallelly go two reactions. There may be parallel reactions. A gives C, A gives D. There might be parallel reactions. This means D is not intermediate by definition. Now what you have to do? You have to write this definition. Intermediate is a product for one step of a reaction and reactant for another step of a reaction. Pause the video and write definition. Now write these examples. Now let us consider a first intermediate. Let us consider a basic reaction. For example, we have an alkyl halide and this bond shift toward chlorine. Now what is the meaning of this arrow? This arrow means movement of two electrons from tail to head. If I draw this arrow, this means there are two electrons moving from tail to head. This is tail and this is head. Got it? So if I drawing this arrow, this means two electrons are moved toward chlorine. So this means chlorine will get negative charge and this R will get positive charge. So in order to undergo bond formation, we require two electrons. Okay. Out of two electrons, one contributed by chlorine and one from carbon. And if both electrons are giving toward chlorine, both electrons are shifting toward chlorine, this means one electron of chlorine itself and one it abstract from the alkyl group. It abstract from the alkyl group. This means there will be negative and positive charge. Now further OH minus will react, it will convert into alcohol. Now this R plus is intermediate and this R plus is known as carbocation or carbonium ion. What is the meaning of carbocation? Cation on carbon. Carbonium ion means positive charge on carbon. This nium represents positive charge. For example, hydronium ion. What is the meaning of hydronium ion? H plus, H3O plus. Nitronium ion, NO2 plus. Halonium ion, X plus. Bromonium ion, Br plus. Nium means positive charge. Got it? Now, we have to explain the intermediate of this. R plus means carbocation. So first of all, write down this carbocation. Now how carbocation are formed? If both electrons are shift toward chlorine, if I move both electrons toward chlorine, carbon has positive charge and this is known as carbocation. Now what is the hybridization of carbocation? Because there are only 3 sigma bonds, means it is a sp2 hybridized. And there is a vacant p orbital. The p orbital and sp2 atom must be perpendicular to each other. So this is sp2 hybridized, it is a vacant p orbital, and since there are 6 electrons, this means it is a electron deficient carbon. The carbocation have vacant p orbital, it is a electron deficient carbon and it is formed by heterolytic fission. Now what is the meaning of this heterolytic fission? If both electron move toward chlorine or move toward carbon, this means a unequal distribution of electron. Then it is known as heterolytic cleavage. One more cleavage is there. There is a homolytic cleavage. Homolytic means equal distribution of electron. Heterolytic means unequal distribution of electron. Therefore, in this case, both electron move toward chlorine. Therefore, it is a heterolytic fission. You write down in your notes, it is a carbocation, vacant p orbital, electron deficient, 6 electron, sp2 hybridized, and it is formed by heterolytic fission. And one more thing, carbocation are also known as electrophile because they are positively charged. Since they are positively charged, therefore they are electron loving, means it is a electrophile. So carbocation are sp2 hybridized, vacant p orbitals, 6 electron formed by heterolytic fission, and it is electrophile. You can also understood heterolytic fission. For example, if any person has 2 kids and among 2 kids he give all his property. For example, the person has 2 kids, one name is methyl, another name is chlorine, and he gives all his property to chlorine. Means he donate or he write will, in his will he write all the property to chlorine. This means chlorine become electron rich and carbon become electron deficient, means unequal distribution of property. This means it is a heterolytic fission. And if he divide his property equally among carbon and chlorine, then it is known as homolytic fission. Now, we have to determine the stability of cation. The hybridization of carbocation is sp2 hybridized and methyl is sp3 hybridized. This means it is more electronegative. This means methyl will show plus psi effect. If methyl is donating electron to carbon by sigma bond, this means there will be a delta positive charge on this carbon. Got it? How to determine stability? More the dispersion of charge, more will be the stability. if charge is concentrated, this means it is highly reactive toward nucleophile, and if charge is dispersed, this means it is more stable because it is less attracted toward any negative charge. More the concentration of charge, more easily it will react with negative charge. This means more the dispersion of charge. What is the meaning of dispersion? More the different carbon will carry that charge, more will be the stability. So more the dispersion of charge, more will be the stability. Now let us consider these three examples. First of all, it is a 3-degree carbocation. How 3-degree cation? Because this carbocation directly attached with 3 carbon, 1, 2, 3, 3 degree. Similarly, it is a 2-degree cation because this carbocation directly attached with 2 carbon. Similarly, it is a 1-degree cation because this is directly attached with 1 carbon. So definition of degree is clear, 3 degree, 2 degree, 1 degree. Now 3 degree is the most stable cation. Among these three, 3 degree is most stable. How 3 degree is most stable? Because methyl is showing plus I effect. As we know, inductive is an additive effect, plus I and plus I. Since carbon is electron donating, this means it become electron deficient. This carbon is electron donating, this means electron deficient. This is donating, this means it is electron deficient. Now this carbocation will disperse, apart from this carbon, this positive charge will disperse in 3 carbon. Got it? Apart from this positive charge, this carbon is dispersed in 3 carbon. Similarly, in 2-degree cation, this showing plus I effect means delta plus I effect means delta plus. So apart from this positive charge on this carbon, this positive charge dispersed in 2 carbon. Similarly, it is showing plus I effect means delta plus. This positive charge is dispersed in 1 carbon apart from this carbon. So in which carbocation there is a more dispersion of charge? The first one has more dispersion of charge, means it will be the more stability. So write down this example, 3-degree cation is more stable than 2-degree cation is more stable than 1-degree cation. Now, you have to remember that if there is a plus I effect on carbocation, it is stable because of dispersion of charge. If there is although carbocation are electron deficient, and if we introduce minus I effect, this means the positive charge become more deficient, means it is highly unstable. Means plus I effect will increase the stability of cation, minus I effect decrease the stability of cation. We can understand in general life, for example, carbocation are just like a beggar, someone who is asking for money or something like that, and we are asking money from beggar. This means the beggar become more beggar. Got it? Any deficient become more deficient. This means it is highly unstable. So we usually do not ask money from beggar. Means carbocation directly attached with minus I is unstable, carbocation directly attached with plus I is stable. So write these 2 points, plus I is directly proportional to stability of cation, minus I is inversely proportional to stability of cation. Means the carbocation and plus I must be nearer to each other, and minus I and carbocation must be away from each other. Got it? So write in your notes, plus I directly proportional to stability of cation, minus I inversely proportional. Now, try these examples, then I will explain the answers. Pause the video, write down all these examples. Now, in first example, which one is more stable? Let's check the answers. These are the answers. Now you have to check your answer. If any of that question is wrong, then you have to think about it, why it is wrong. Now in first example, this 3-degree cation and this is 2-degree cation. More plus I, more stable cation. This is 3 degree, this is 2 degree. Means 3 degree is more stable than 2 degree. In this example, as we know that plus I of D is greater than plus I of H, this means first is more stable than second. because plus I of D is greater than plus I of H. In third, this is our 2 degree carbocation because of 2 plus I, and this is also 2 degree. I will change that option because they are almost similar. This carbocation must be there. Let me. We have to change that option. Slight change, slight correction. Now, if this is 2 degree, this is our 3 degree. This is more stable. In previous question, they are almost similar. Almost similar, not almost similar. Sorry. We don't have to change that option because we can explain by inductive effect. Correct. This is positive. Both are 2 degree. Both are 2 degree. But this is nearer to this methyl. This means second is more stable. Got it? The original question, both are 2 degree, but plus I is nearer. Plus I is away. This means second is more stable. In fourth, it is so plus I means stable, minus I means unstable. First is more stable than second. Means no need to change the option in third. Now try these examples. Now what is the answer for fifth? Plus I and plus I. What is the degree? 3 degree. And in this case, it is a 2 degree, so which is more stable? 3 degree is more than 2 degree. In sixth, this is so plus I effect minus I, which is more stable? First is more stable. In seventh, this chlorine so minus I. Minus I means inversely proportional to stable. More unstable, more minus I, more unstable. Minus I must be away from the cation so that minus I will be weak. So in this example, minus I on third carbon. In this example, minus I on fourth carbon. So it is away means it is a weaker. Weaker means more stable. Plus I must be nearer to the cation. Minus I must be away from the cation. Now in eighth, first is more stable than second. Why? More deuterium, more plus I. More D, more plus I, more stable cation. Got it? Now let us discuss second intermediate of the reaction. Now the second intermediate is carbanion. What is the meaning of carbanion? This is carbon and anion means negative charge on carbon is carbanion. So let us assume both bond pair are shift toward chlorine. Although this is not the case, usually bond pair shift toward chlorine, not toward carbon, because chlorine is more electronegative. Let us assume to explain carbanion, bond pair is shift toward carbon. If bond pair shift toward carbon, this means chlorine has positive charge, chlorine will have positive charge and carbon will have negative charge. Therefore, it is known as carbanion, negative charge on carbon. Now, since there are 3 bond pair and 1 lone pair, this means it is our sp3 hybridized. We will count lone pair in hybridization, therefore it is a sp3 hybridized. How many electrons are there? 8 electron. It is electron rich. Rich means in terms of negative charge, not in terms of octet. It is a nucleophile. Since it is a negative charge, means it is a nucleus loving. Positive charge loving means it is a nucleophile. And what is the type of fission? It is a heterolytic fission because both bond pair are moved toward carbon. In this case, the property is given to one person only and that person is carbon. Carbon become rich and chlorine become deficient. Means unequal distribution of property, unequal distribution of bond is known as heterolytic fission. So pause the video and write this example. Write all the theory related to carbanion. Now, since it is a electron rich, negative charge is there, if there is a more plus I, more the concentration of negative charge. Means negative charge density will increase. This means it is unstable. We want distribution of negative charge. We don't want negative charge will be concentrated on one atom only. This means plus I destabilizes carbon ion, and if there is a minus I effect, there will be distribution of charge. This means their stability will increase. More minus I, more distribution of negative charge. Minus I means it is the electron withdrawing. This means it will carry partial negative. More minus I, more atom will carry negative charge. This means more dispersion of negative charge. So we can say that minus I is directly proportional to stability of carbon ion. Plus I is inversely proportional to stability of carbon ion. And minus I and carbon ion must be nearer to each other. Plus I and carbon ion must be away from each other. Now in this example, now the stability order will be reversed, because more plus I, more will be the concentration of negative charge, more will be the unstable carbon ion. This is highly unstable because of presence of 3 plus I effect. It is relatively more stable, 2 plus I effect. It is more stable because of less plus I effect. So more the plus I effect, more will be the negative charge density on carbon, more will be the unstable. This means order will be 1 degree, 2 degree, 3 degree. It is the reverse order of carbocation. Carbocation are deficient, carbon ion are electron rich. So write down this definition, write down this example, stability of carbon ion. Now try these examples. Pause the video and try all these examples. Now these are the answer. Now in first case, methyl shows plus I effect. Plus I means unstable carbon ion, NO2 shows minus I, therefore it is more stable. Minus I is directly proportional to stability of carbon ion. Second, chlorine shows minus I. Minus I and carbon ion must be nearer to each other. In this example, minus I on third carbon. In this example, minus I on second carbon. This is nearer. This means more stable. Now in F and Cl, F is more electronegative, more power of minus I. More minus I, more stable carbon ion because of power of minus I. In fourth, again this is more stable because minus I is nearer, minus I on second carbon. In this example, minus I on third carbon. Now in fifth, this is 3 degree carbon, 3 plus I. And this is 2 degree carbon, 2 plus I. This means 3 degree is unstable carbon ion. Now in this example, stability decreases. Why stability decreases? What is the difference? It is sp hybridized, sp2 hybridized. This means it will showing minus I, and it is again showing minus I. But hybridization of carbon is sp2. If I ask you which shows more minus I, so sp is more electronegative means more minus I, means it is minus I is more powerful than minus I of alkene. Got it? So this means alkyne, more minus I means more stable carbon ion. So this is the most stable carbon ion. And in this case, alkyl shows plus I. This means it is unstable carbon ion. Got it? Means the minus I decreases, stability decreases. There is slight change in this example. Replace this by chlorine. if there is a 2 chlorine and if there is a fluorine. This is more stable than this. Now what I want to explain you, in this case we have 2 minus I. There is a 2 minus I. And in this case it is only 1 minus I. So which shows more minus I effect. Inductive is a additive effect, means 2 minus I effect dominate 1 strong minus I effect. Means 2 minus I effect dominate 1 strong minus I effect when it is placed at same distance. The distance from this oxygen is same. This is on second atom, and in this case minus I on second atom. Means distance from negative charge is same. 2 minus I effect dominate 1 strong minus I effect. We can take example of that movie Bahubali. In Bahubali, the Bahubali and the second character name is Bhalal Dev. Although these two are weaker in compared to the enemy of the large enemy, but since they together fight, they are additive effect, so they overcome the strong enemy, strong army. This means just like a Bahubali, 2 minus I dominate 1 strong minus I. Bahubali means the main character and his brother Bhalal Dev. So write in your notes, 2 weak minus I dominate 1 strong minus I. 2 weak dominate 1 strong minus I. It is to remember, point to remember, you have to remember this. Now in this example, which is more stable? The first is more stable because inductive is a distance dependent. Minus I and negative must be nearer to each other. In this case, minus I is on third, means distance is more important. Now in example 9, we have 2 options. This is shows fluorine shows minus I because of more electronegativity, but it is at second distance, means it is nearer to the carbon ion. Means if we compare distance, then this is nearer and this is away. So according to distance, the first is more stable than second. But if we compare power of minus I, so minus I power is NO2 is greater than F. If you see the order of minus I, you will find that positive charge strong minus I, then NO2, cyanide, then fluorine. In order of minus I, NO2 minus I is greater than minus I of F. Got it? Now, distance versus power. Which is more dominant in inductive effect? Preference will be given to distance because it is a distance dependent effect. Once the one carbon will increase, the significant decrease in inductive effect. Means distance will dominate power. This you have to remember and learn. Whenever, if there is a variable of distance and power and variable of inductive effect, preference will be given to distance. It is just like that. For example, if we need some help, the preference is not given to the powerful person or powerful relative who live away from us. The preference is given to the person who is living nearer to us. Means the neighbor, you should have good relation with your neighbors because they are nearer to each other in comparison to the relative which is distance relative. Got it? So just like neighbors are important, similarly distance is important in inductive effect. So that's all for today. Hopefully you have, if you liked my lecture, then please subscribe my channel and please tell other, especially the students who are studying in the South India, please tell among your friends in school, in coachings and your teachers also regarding my YouTube channel, so that you can get maximum benefit from my YouTube channel. And it is free, so that you can use as a supplementary education, you can use as a whatever topic you are feeling very weak, you can just watch from my YouTube channel And not only watching, you should solve DPP and class test also. Along with this lecture, I am also uploading DPP class test, so that you can do a complete practice. Just first of all, you have to watch the lecture, then you have to prepare short notes, then you have to do DPP. DPP means daily practice problems. That is a very famous short term name in KOTA. And fourth one is class test. If you solve all this, then your topic will be very good. Thank you, and we will meet again.